Now we are happy to have Arvind to do the USACO Silver Live solution for this just finished December contest. Arvind, he's a ICPC, International College Programming Contest World Finalist. He has been teaching XCAM for several years. We are so happy to have him here to share the solution. Hey, Arvind, turning the stage to you.
Hey everyone. I'll just first give an overview, I guess. Okay. Yeah. Let me share my screen. Yeah, so this contest had 3 problems. I guess they were in roughly increasing order of difficulty. And I'll go back to this later, but I think for many people, cake game was the easiest, and this was the hardest. And yeah, these are like topics that ended up being the solutions, but I'll go over the problems. Yeah, so I'll change my screen share. Yeah, so the first problem, which I guess is the easiest for many of you, was the problem cake game. So basically there's there's a row of n cakes where n is even, and their sizes are A1 to AN. And Bessie and Elsie take turns, right? So either Bessie takes 2 adjacent cakes, and then kind of merges them so that it's the sum. So if like this is something Bessie might do. So if it's 3 here and it's 5 here, then Bessie might merge it and then it'll become 8. And then Elsie, given all the cakes, will choose the leftmost or rightmost cake and then take it, right? We can go over some samples. So this is an example sample input. So for 40, 30, 20, 10. I guess Bessie can merge these two first. So it becomes 40, 50, 10. And then Elsie can take this 40, and then Bessie can merge these two. And then Bessie will get 60, and then Elsie will get 40. And then it's the similar thing for this, right? So I think, yeah, so one thing that can be useful to look at is what are the subtasks? Yeah, I think this case is also kind of similar. So the first subtask is where all the elements are equal, right? So yeah. So let's consider the case where all the elements are equal, right? So the first one will be x. So you can assume they're x, 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 right? These are all the cakes. And one thing you can assume is that they're just all 1. Let's just assume they're 1s because the solution will be the same. You'll just have to multiply by x, right? I guess there's an even number, so there'll be 6. So let's look at some small cases for where there's 1s, right? So if there's one cake that's 1, one cake that's 1, then in the case for n equals 2, Bessie can merge these together, and then the answer will be 2. And then in the case where n is equal to 4, Bessie can merge these together, so it'll become 1, 2, 1. And then Elsie will take one of these, and then Bessie can merge these together. So the answer will be 3, right? And then we can look at 6 1s. So Bessie can merge these together. It will become 1, 1, 2, 1, 1. And then Elsie may take something in the edge. And then Bessie can merge 2 of them together. So it'll become 1, 3, 1. And then Elsie may take this, and Bessie will merge this. So this gives 4, right? So yeah. So notice that like yeah, so here we have like n is like an even number, right? So we can kind of guess a pattern here, right? So like this is 2 yeah, so we can guess a pattern. just based on these cases, when n is 2, answer is 2, n is 4, answer is 3, n is 6, answer is 4. So the answer may be something like k plus 1, right? Good idea. Can you do that? Does that work? I guess if you want, you can take a screenshot of this. I'll give like a few seconds. Okay, so I assume people have taken screenshots of this. And I'll also scroll down to the subtasks. Yeah, these are the subtasks. All the elements are equal. N is at most 10. N is up to 5,000. And the original constraints, I think it's like 10 to the 5 or um, 5 times 10 to the 5. Yeah, right. So yeah, so for the case where they're all equal, we see this kind of pattern. And then we can prove that the pattern actually works. Sorry, just give me one moment. Yeah, so we can prove the pattern works. Sorry. Okay, I think it's fine. Yeah. So yeah, so there's a pattern that you can kind of like guess by looking at some samples, but you can prove it will work, right? Because LC will always take k minus 1 steps. So LC score is at least k minus 1, and then the sum of both of them will be 2k, right? So then that will mean that Bessie is at most k plus 1, right? So we know that when they're all equal, the answer is equal to k plus 1, right? Then we can kind of guess like how to do the original problem based on this, right? So we can look at, in this case, where this 2 came from. It came from the entire array. And then where did this 3 come from? It came from this array here. And then where did this 4 come from? You can keep tracing back. There's 3, 1, and then there's 2, 1, 1, and then there's 1, 1, 1, 1. So it came from here, right? So in these cases, the answer came from some kind of subarray, right? And then if you like look at these cases, like Bessie scores like from this subarray of length 3. Bessie scores from this subarray of length 3. Yeah, and then here it's from this subarray of length 3. I guess these cases are the same. But one thing like you can kind of maybe try guessing is maybe the answer is some kind of subarray, right? So maybe Bessie like does all the operations here, and then LC does all the operations here, right? So maybe a reasonable guess, um, for this problem is that answer is the smallest subarray sum. Right? And it turns out this is really short to implement, right? You can have prefix sums, and then each subarray is going to be of the form like pre I plus k minus pre I. Yeah, so this is maybe like 7 lines implementation. It doesn't hurt to like guess and just try it. And it turns out it works, right? Yeah, any questions? I can talk a little bit more about intuition about why it works. But yeah, okay. Yeah. So the idea is like, yeah, so consider you have like an array. Yeah, so this is how I did the problem. I didn't try proving it when I did it. I just guessed and it worked. But we can also, it's also good to be able to like understand why it works. So just consider a case. Yeah, so essentially like during the process, like this will be merged into pieces. And Bessie doesn't want Bessie doesn't want Elsie to be able to eat these pieces, right? So Bessie can start here. And then Elsie can pick one of these two ends, right? So if Elsie picks, I'll just change the color. So red is Elsie. So if Elsie picks this one, then it's a bad idea for Bessie to merge these two, right? Because if Bessie merges these two, then Elsie can take the entire thing, right? So if Elsie takes the leftmost, then it's better for Bessie to merge this with whatever's to the right, right? And then Elsie will take one of these, and then Bessie will take the entire thing, right? Yeah, any questions? So essentially, Bessie picks the center in the beginning, and then whatever Elsie does in the beginning, so if Elsie picks the left, it forces Bessie to pick the right, because Bessie doesn't want Elsie to have the big block. And then if Elsie picks the right, then Bessie will pick the left. Yeah. So basically, Elsie can force any subarray of length k plus 1 to be picked. Oh, how do you find k? So I just define n is equal to 2k. N is an even number. And then Bessie's thing is a k plus 1 length subarray. Yeah, that's how you define k. Any other questions? Right, great. I'll move to the next problem then. Okay.